Good morning, my YouTube viewers. It's Crystal here, and in this video, what we're going to talk about is the Holt Winters model. In the last video, we discussed the ARIMA model, and in this video, we're going to be talking about Holt Winters. And the Holt Winters is a special type of ARIMA model. The main difference between the Holt Winters model and the ARIMA model is the fact that on the ARIMA model, you have to set up your PDQs, but on the Holt Winters model, you don't have to do that. So, yeah, if you don't want to set up your PDQs, then the Holt Winters model might be a good model to use. But what I would suggest is if you have time series data that you run it up and you want to make a prediction, you run it up on the ARIMA model and the Holt Winters model, and you select the model that has the lowest error in it, has the lowest RMSE, that's root mean squared error. But there are some instances when RMSE doesn't work, and they have something called AIC. So you could run a test on the AIC and see which AIC has the best value. Unfortunately, in the programs that I'm using, I haven't calculated the AIC, but I'm sure that you could, it wouldn't be a difficult matter to find out how to calculate the AIC. But in this particular video, what we're talking about is the RMSE, that's root mean squared error, and that's going to be what we're going to be testing. We're going to be testing for the error. And so that's what I would suggest you do, that on the, if you have data, you run it up on the Holt Winters model and you run it on the ARIMA model, and you select the model that has the lowest error, which is RMSE, or the best AIC reading. But unfortunately, I don't have AIC in any of these programs, and the reason why is because I didn't think about it until just now. But AIC is another goodness of fit test. And then so in this particular video, we're just talking about Holt Winters, and in the next video, what we're going to talk about is a comparison between the ARIMA model and the Holt Winters. So the Holt Winters is a triple exponential smoothing method. It maintains three components that update every time, being level, trend, and seasonality. Each component is updated by exponential smoothing, meaning recent observations get more weight than older ones. The Holt Winters model can be used when the trend is clear, there's a repeating seasonal variation, there's a smooth, repeatable behavior, and there's no sudden structural breaks. So that's just a little bit of information on the Holt Winters model. And so now what we've got is we've got a computer that we're going to a computer program that we're going to review the code. And then on this, and then so you can see how the Holt Winters model works. So the first thing that you want to do is you want to set your seed. And the reason why you set your seed is so that every time you run the program, the variables are going to be initialized to the same value. So you're going to type set.seed brackets 1, 2, 3, and you can put any number you want in the brackets. So now we're going to create some synthetic seasonal time series data. So time is going to be 1 to 120. And so that's going to be like a vector with the numbers 1 to 120 in it. So your season is going to be another vector that you've created, and it's going to be a repetition. And there's going to be a vector within a vector with 10, 20, 30, 20. So that's four particular elements in that vector, and each element has 30 elements in it. So 4 times 30 is 120. So that means you're going to have a seasonal repeating pattern. And y, which is your dependent variable, becomes 100 plus 0 plus 5 times time plus season plus R norm brackets 120 and ST equals 5. So R norm is a randomly sampled normal distribution that has 120 samples in it, and it has a standard deviation of 5. And then so now what we're going to do is we're going to create this time series data. So TS data becomes TS, that's time series, brackets Y, that's your dependent variable, with a frequency of 12. So and then what we're going to do is we're going to plot the original data. So you plot brackets TS data, main is the title, which is synthetic seasonal time series. Y lab is your label on your y-axis, which is your value, and X lab, which is a label on the x-axis, which is time. So now we're going to fit the Holt Winters model. So we're going to fit the Holt Winters model, which is going to be level plus trend plus seasonality. So HW model becomes Holt Winters, which is a function in R, and it's going to do the time series data. And so you'll notice that this is so much different from the ARIMA model, because on the ARIMA model, you have to calculate the PDQ, which is what we did in the previous video. But on this model, all you do is you do Holt Winters. Holt Winters uses exponential smoothing, and Holt Winters calculates it for you automatically. So Holt Winters is more of a black box than ARIMA is. So we're going to forecast for the next 12 periods. So HW forecast becomes predict, brackets HW model, and then in ahead equals 12. And then we're going to plot the actual and the forecast. So TS.plot, brackets TS data, comma, HW forecast. Color is a vector that you've created, being black and blue. Line width is a vector that you created, being 2, 2. Main is the title of the plot. It's going to be Holt Winters forecast base R. Y lab is the label on the y-axis, which is value. And then we're going to put a legend in there. So the legend is a vector that you've created, being actual and forecast. The color is a vector that you've created, but actual is black and forecast is blue. The line width is 2. Now we're going to create the RMSC. So RMSC in sample becomes square root, brackets mean, brackets TS data minus fitted values to the square root of 2, and NARM equals true. And you're going to print RMSC in sample. So I'm just looking for fitted values in here. So we're going to fit, it says HW model. And fitted values is like it's in the HW model. I'm just looking for the fitted values in the code, and I don't actually see the fitted values in the code, but the program worked, so it worked with the fitted values. But what I'm going to do, just to make sure, I'm going to run it again. And that didn't work. So obviously there's a problem with the fitted values. Fitted values not found. So let me look and see. Let's try it that way. So it worked that way. So we calculated our RMSE. So it doesn't take fitted values. It takes HW mode, $, fitted, square brackets, comma, X hat to square. So that takes the fitted value. So this is the plot that we have created, and that is the original data, original synthetic time series data, and it has values from, well, about 100 to close to 200, because the way we set it up is 100 is your base value. So it goes up to 200 all the way up to about 100 all the way up to 200. And then basically, so we've got 120 elements, which are divided by 12. So that means so you're going to have 10 periods. So we've got 10 periods here. So we've got our RMSE as 5.4. So you've got an RMSE of 5.4. That's your root mean squared error. And then now we've got our forecast for one period for the next 12 units. So again, you've got your actual value, which is black, and your forecast value, which is blue. So you can see the actual time series data that has an upward trend, and then in the black, and then at the last bit, which is going to be 12 units, is going to be the forecast. So you see the RMSE 5.4 and the actual data with the trend. So that's going to conclude this video. And the next video, what we're going to do is we're going to compare the ARIMA model to the Holt Winters model to see which one works best. And the reason why is because when you're working on time series analysis, you're going to want to pick the best model. So although the Holt Winters model is a special case of the ARIMA model, you don't have to calculate the PDQ in the Holt Winters model the way that you have to calculate it in ARIMA. So what we're going to do in the next video is we're going to take a program, we're going to take some synthetic data that we've created, we're going to run it up in Holt Winters, see what our RMSE is, and we're going to run it up in ARIMA and see what our RMSC is. And then so we're going to select the module that gives you the least error or the least RMSC. And the thing is that I haven't put it in these programs, but you can also calculate AIC. So there's going to be some cases that I've noticed, like when I was preparing my data for this video, that some cases the RMSC doesn't work. And so in that case, it might be better to calculate an AIC. But we're not going to do it in this video because I've already written the programs. But that's just something that you can think about if either you don't want to use RMSC, but RMSC is what most people use, or you can't use RMSC because there's a problem. So that concludes this video. The next video is going to be a comparison between ARIMA and Holt Winters. I hope that you get something out of that video, and I hope that you got something out of this video.